My name is Kartikeya Veermraju. I'm a graduate student in electrical engineering, and my area of research is in the development and design of power processor units for electrospray thruster systems. So these are a lot of words, so let me break them down. So nanosatellites have become very famous lately because they help in students doing research in the field of aerospace, and which would otherwise be only possible if they were working in an aerospace organization like NASA or Blue Origin or SpaceX. And so one of the major issues that happens during this miniaturization process is that they have to miniaturize a thruster, which is very complicated, and it is the meat of the satellite because that helps in orienting the satellite in the proper attitude and in a proper position. Now, for that to happen, actually we need to make sure that the satellite is properly spaced and all the volumes are correctly taken into consideration. Now, anyone can be a rocket scientist actually. All you need to do is take a can of deodorant and spray it in space. Basically, that's that. But a more complicated form of a thruster is an electrospray thruster. Now, an electrospray thruster basically takes a molecule, applies a very high voltage across it, splits it into ions and ejects the ions outside the satellite, and that causes an ionic wind, which basically helps in orienting the satellite in the proper attitude. Now, for this to happen, the major challenge is that we have to have high voltages in the first place. But satellite has a very low voltage battery on board. So my research is basically in the design and development of such power processor units which can boost those voltages to those high voltages so that this electrospray phenomena is possible in the first place. So the previous implementations done by the PhD students has been shown in the top figure, and we can see that there is a voltage over there, and it's at 3.4 kilovolts, and it has been boosted from 15 volts. But that's task accomplished. But the problem is that there is a voltage ripple over there, which would basically contribute to an uneven thrust. And we are already in an unpredictable environment, and an unpredictable thrust is not something that we can afford. So we go for another kind of a converter, and this has been proposed by me. And we see that the voltage over there is pure, and it's a pure DC signal, and there is no jitter as we have seen in the previous case. And so the thrust that would be caused due to such a voltage would also be steady, and it's a more predictable system, and that is what we want. And also the final product that we come up with, or the prototype that we come up with, has to be small enough so that it can fit in one's hand. That's my hand for scale. And so this has been my research.
Thank you.